Hi friend, how are you? I hope everyone is good. Now again I am coming in my video. This video is continued my previous video. Previous video. This video I will discuss about the bar bending schedule. This video I will discuss about the detail of the bar bending schedule, why we are using the bar bending schedule, or what the benefit of the bar bending schedule. Now this video I will start the bar bending schedule in beam. How to calculate the beam steel. This video. This video also we are making the one table. This beam diagram. How to calculate this beam all steel. How much you use the steel, and I make the one table. This is the I will use the small diagram. This one. Sometime we are you go inside there the big drawing there. So this drawing I will divide the one part, two, three part by, and then one part I calculate this one, and second part, third part, fourth part, and last time we are calculate the all parts and get the steel value. So this video I will use this diagram and get the steel and we are get the steel value. So here show the detail of the beam. This beam clear span is 5 meter. This beam clear span is 5 meter and 5000 millimeter. And millimeter of two bottom layer. Here so the bottom layer we are using the two bottom layer. Means bottom side I will use the 4 bar. 2 bar is 20 millimeter dia and 2 bar is 16 millimeter dia. And upside we are using the 2 bar. This bar dia is 12 millimeter. And also here provide the span. This span is 150 millimeter, and this beam divide the 3 zone. So second zone has we are using the 8 millimeter dia stirrup, and then and with a spacing of 200 millimeter maximum. Here so the zone, first zone, second zone, and third zone. So we are using the stirrup. This is stirrup, but this is stirrup diameter is 8 millimeter, but center to center different. First zone we are using center to center 15 millimeter, 150 millimeter, but second zone we are using the center to center distance 200, and again zone 3 we are using the center to center distance 150 millimeter. This is the decided here. The two zone we are using the center to center distance 150, and middle means zone 2 we are using the center to center distance 200 millimeter. Before I will tell the clear spans of beam 5000 millimeter or 5 meter. Then the second thing is development length is LD. Means LD we are using the 50D LD, and then I will use the clear cover also. I will provide the clear cover 25 millimeter, and bottom side before I will tell you bottom side we are using the 4 bar. 2 bar is 20 meter dia and 2 bar is 16 meter dia, and top we are using the 2 bar only. This dia is 12 meter, and this one is stirrup zone 1 and 3 we are using the 8 millimeter dia, and distance is 150 center to center. And zone 2 we are using the 8 millimeter dia, same, but center to center distance is 200 millimeter. So this is the detail of the drawing. This drawing, two part here, zone L by 3, L by 3. Here we are using the center to center distance 150. On middle side we are using the center to center distance 200. Because this is the comfort zone, that's why I will using the center to center distance 200. And this two side is tension zone. So I will using the center to center distance 150 millimeter. So friend, this beam I will divide the step 1, step 2 and step 3 like this. So first of all I will use the step 1, calculate cutting length of top bar. So step first, calculate cutting length of top bar. So here I will use this formula. Cutting length of top bar, clear spans of beam. We are know the clear spans of beam 500 millimeter plus development length minus band. So here so the band detail also. Before my previous video I will discuss about the band. 1D where put the 2D, where put the 3D. We are bending the steel 45 degrees, so we are using the 1D. I will bend the steel 90 degrees, so we are using the 2D, or we are bend 135 this bar, so we are using the 3D. So I choose the this beam we are use the 90 degree bend, this one 90 degree, this one. So that means I will use the 2D because this bar I will bend the 90 degree. So now here we are put the value of this one. So I know clear spans of the bar beam 5000 plus development length here 2D, 50D. So 2 into 50 into 12. 12 is the diameter of the bar and the minus the bend detection. So here see this one 2 times, 2 side I will bend the 2 side, this one right and left side I will bend the 90 degrees. That means I will put the 2 into 2D and the D value is 12. So 2 into 2 into 12. So now we are getting the here value 5000 plus 2 into 50 into 12. 12 is the value is D, diameter of bar, minus 50. So now we are getting the answer. Here 6152 millimeter. This first step. Then second step, calculate the cutting length of the bottom. Bottom side we are using the 4 bar. 2 is the 20 and 2 is the 16 diameter. So first of all we are calculate the 20 millimeter dia bar. So cutting length of the bottom bar equal to clear spans of the beam plus development length minus band detection. So here put the 5000 plus 2 into 50 into here. This is the formula, cutting length of L in plus 2 into LD minus 2 into 2D. So I will put the value of this. I will put the value of this formula. So L I know L equal to 5000 plus 2 into 50. LD means development length into here we are calculate the 20 millimeter dia. So I will put here the 20 minus 2 into 2 into 20 because I will use the 20 millimeter die. So I will solve this one. So I get the answer 6920 millimeter. Again repeat this process, but change only dia. Here using the 20 millimeter dia. Now here using the 16 millimeter dia. The same formula, cutting length equal to L plus 2 into development length minus bend detection. So here length is 5000 plus 2 into 50 into 16. Why I put the 16? Because this time I will use the 16 millimeter dia. So I will put the dia value is D value, dia value is here, minus 2 into 16. So I will solve this equation and I get the answer is 6536 millimeter. 6536 millimeter. So now we are going step 3, calculate the number of the stirrup. So here this were the so friend, this is the third step. We are calculate the number of stirrup. So this beam we are divide the 3 zone, first, second and third. So zone first and second we are using the 8 millimeter dia, but center to center distance is 150 millimeter. So here I will put this beam, I will divide the 3 zone, 1, 2 and 3. This L by 3, this L by 3 and this also L by 3. So this zone first and zone third, center distance 150, and this second zone center distance 200 millimeter. Stirrup is same, 8 millimeter dia. First we need to calculate the length of the each zone. मतलब this every zone length, zone first, zone second and zone third. So L by 3 equal to 5000 upon 3 equal to 1666 millimeter. So I get the value of one zone length, 1666. The number of stirrup required for zone first. Clear spans of beam, spacing of stirrup plus 1. So I know the value of the clear spans of the beam. Now here I will get the value 1666 upon spacing of stirrup. The first zone here is center distance is 150. That's why I'll put the 150 plus 1. I solve this value, I get the answer is 12.10, means 12. So I get the answer is how many stirrup used this first zone is 12. Number of stirrup is 12. 12 stirrup I use this first zone. Then same like this, number of stirrup required in third zone. Because first zone and third zone is length is same, so maybe and center distance also same. So this stirrup number and first stirrup number and third stirrup number is same, 12. So now we are getting the zone 2, because zone 2 center distance is 200 millimeter. So again I will put the clear spans of beam. One, and here get the value 1666 upon 200, because zone 2 center distance is 200 minus 1. Then I solve this answer equation, I get the number 7. It just means zone 2 we are using the stirrup is 7. So first zone, second and third zone I will get the answer. I know the how many stirrup use this zone. Now going next part. Our friend, I forgot this one. Here I will already add the one stirrup, and second one, the first joint and second joint, I will already add the extra one. That's why I will use here -1, because I will use the continue this one. So I will already add the +1 here and +1 here. So no need for again +1 in second joint. Just why I will minus the -1 here, this one. So friend, this is the cutting length of stirrup. So this stirrup, this beam size is 500 and 300. This beam size is 500 into 300, and band detection is 25. I know that we are band 25 degree, so 190 is 2D and 135 to 3D, and this is the value. Cutting. This is the cross section of the stirrup. Width is 900 millimeter. Height is 50 millimeter. Is the horizontal length of stirrup. So here 300 minus 2 into clear cover minus 2 into half of band detection, because here full length of 500, but this is the length is this is the beam length, but here also I provide the clear cover, so I minus this clear cover, so I get the length of the stirrup. Also here clear cover, here clear cover, so that's why I will minus the clear cover. Two side I will provide that two side ones and two, so 2 into clear cover. And also I will minus the band detection. Here this is the band 90 degree 90 degree, so I will use the minus also the band detection. So 300 minus 2 into clear cover, we are using the 25 millimeter, so 2 into 25 minus here 2D, two side 2D here and 2D here, because we band the 90 degree and 90 degree here, two side now. So we are using the 2D and 2D means 4D, 2 into 4. I solve this equation and get the answer is 242 millimeter. B is vertical length of stirrup. This one is B. This one vertical length of stirrup here. So for now I will get the value of this A, width of stirrup length. Now we are I will use the same formula and get the value of vertical length of stirrup, this B1. Now I will get the answer of A. Now we are using this formula and get the answer of B. So here B total length is 500 millimeter minus clear cover 2 into 2 side, because I will use that 2 side as clear cover. So 2 into clear cover minus 2 into half of the bar band, half of the bar dia, 500 minus 2 into 25 minus 2 into 4. So I will solve this equation and get the answer is 442. Now calculate cutting length of stirrup. Cutting length of stirrup. So cutting length equal to 2 into A plus B plus hook minus band. Now we are getting the value A is 242. A equal to 242 millimeter and B equal to 442 millimeter. Now get the I will put the value in here, this formula. 2 into 242 a plus 442 plus hook length 290 into 2. Why 90? Here 1 2 3. There is two hook length. Hook length is 90. So here is two side now. This one 1 and 2. So here put the hook length is 90 into 2 because the two side of hook, two hook is there. Minus 3D into 2 bar minus 3D. Why 3D? Because this angle put the band is 150, 135, 2 times, 1 times, and this is all 2 times. So here put the minus 3D into 2, minus 2D into 3. Why? Because band the 90 degrees 3 side, 1 2 and here 3. This means here put the 2D into 3. Here so the also two number of the band 135. That's why I will put the 3D, and 3 times of band is 90 degree. That's why I will put the 3D, 2D into 3. 3 times of band is 90 degree, 2 times of band 135 degree. So I solve this equation, I get the answer 974 millimeter, means 0.97 meter. This is the stirrup cutting length. Now calculate weight of stirrup. Total number of stirrup 12, zone first 12, zone third 7, zone second. I calculate this one. So total stirrup is 31. Total length of stirrup 0.97 into 31 equal to 30.91 meter. This is the total length of stirrup. And now total weight of stirrup 2D into L upon 162. That is the formula. Here put the value. D is the diameter of bar. So stirrup we are using the 8 millimeter. So 8 into 30.19 upon 162 equal to 12 kg. 12 kg of stirrup we are using the 12 kg of steel we are using the stirrup, making the stirrup. Now I get the value of total weight of stirrup 12 kg. Now this is the bar bending schedule table. Diameter of bar, number of bar cutting length, total length or total weight. So I will, this is total bar 12 diameter 2, then length also calculated there, then I get the length 6.1. wait I will here. Top bar we are using the 12 millimeter dia, or number of bar there 2 bar I will using, and the cutting length is 6.152. Total length, how many? Total length is, I will use 2 bars into 2 equal to 12 into 30, and this weight is 10.93. Now bottom we are using the 4 bar. 2 bar is 20, 2 bar is 20, and length is same 6.920. Calculate this one. Cutting length, total length is 13.984 millimeter, and weight is total weight is 34.6. Again bottom bar, this diameter is 16. 2 bar, we there use the 2 bar. This cutting length is 6.536. Total length is 13.07, and total weight is 20.91. And again here stirrup. We are using the 8 mm die, and this one the number of stirrup 31, and cutting length is 0.974, and total length is 30.91, and total weight is bar 12 kg. So friend, I will use and get the value, and I make the one bar bending table like this, and here put the proper value. Or we are going to side, then use this value, and sometimes we are make the estimate, sometimes we are getting the total how many money I will use this project. So I will read this one bar bending schedule, how much steel is there. So I know the steel rate, 1 kg steel rate. I will calculate that this all kg, and then into the value of 1 kg steel rate, I get the total value of steel. How much money I will expend this beam. So friend, this video we have discussed about the beam. Then my next video I will discuss about the column. So friend, continue to see my video. Okay friend, bye. Again I am coming in another video. This video I will discuss about the bar bending schedule in column. Okay friend, bye.